Guys, welcome back to my channel. So in this video, I'll be taking you through improper integrals type 1. Now, what do you mean by improper integrals? Okay, so in our previous lessons on integration, we realized that for definite integral, you have upper and lower limits AB, right? In cases where A and B are finite, we say that our integral is what? Proper, right? But we have situations where either A or B happens to be what? Positive or negative. In this situation, we say it is improper integral. You are summing to infinity or you are summing from negative infinity. That is the concept of improper integral. So we have special way of handling improper integral because you can't sum from negative infinity or you can't sum to positive infinity using the normal approach. I have a problem here for us to solve so that you understand this concept very well. But before then, saying improper integrals type 1 has two situations or it's so let's see the different scenarios. So you can have from a definite to infinity of f of x dx, right? So to solve this problem, the general approach is to find the limits, right? As you put some unknown here as let's say b, right? As the positive, you put your infinity sign to an unknown variable, then after you find the limits as that unknown variable approaches positive infinity of f of x, f of x dx. Now, the next will be either you are summing from negative infinity towards a point b, right, x. And they are saying that to solve this, you simply have to take the limits where you base our negative infinity with an unknown a, which is being summed to b. Find the limit as this a is infinity of f of x dx, right? Then the third scenario is when you have negative infinity to positive infinity of x. Okay, and for this scenario, we realize that in each case we represented with what? A variable. So the same applies to this. So this is the combination of this and this, right? So here we break our formula into two. We break it into two. Okay, we break it into negative infinity to c, which you don't know, right? Plus integral from c itself to positive infinity of f of x. So this is how we manipulate our improper integral type 1. So now, what do we use improper integrals for? So they are saying that if this limit that we are finding here, if it exists, and you're able to find that limit which is finite, I mean if finite and it exists, then it means that our improper integral will converge in the process of summing because improper integrals is summing to infinity or summing from infinity. So if it happens that the limit is finite, it means that we will converge eventually during our summation. If not, it diverges, meaning that if we cannot finish, right? So let's see the problem here. It says, does the improper integral 1 to infinity of 1 over x squared dx converge or diverge? Does it converge or diverge? In order to solve this problem, you know that this is type 1 because we are having only one of what? Our term here, our limit here to be what? Infinity. That was it. So to solve this problem nicely, the only thing you have to do is you have to apply what you have here. So this is the same as in limits, right? As x approaches maybe b, right? X approaches b, integral. So that is going to fall for this part. This is what you are doing. Integral of from 1 to an unknown 1 over squared. That's it. So from this section, maintain the limit outside and do your integral. That's the most important. So you're having limits at approaches b, right, of this whole thing. When you integrate 1 over x squared, what are you getting? This is the same as h to the power negative 2. So when I add 1, I'll get negative 1, right? Negative 1 power, and I'll have the negative dividing it. So I'm going to have negative 1 over x. Is that not it? Negative 1 over x after my integral. Okay. So once I have negative 1 over x, you put in your limit, which is 1. Okay. Then still we go on, we have limits as x approaches b of negative 1 over x. So here I'll put in my upper limit and I'll put in my lower limit. So putting in my upper limit, I'm going to get negative 1 over b minus, so to be plus 1, right? Because 1 over 1 is 1. So once I have this expression here, what's the limit as s as b approaches infinity? Sorry, I have made mistake here. So as b approaches infinity, so here I was messing up here. Yeah. Let's see. So as b rather approaches positive infinity, as b approaches positive infinity, as positive infinity. So once we do that, the next thing to do is what? Simply know that you are having limits as b approaches positive infinity of 1 minus 1 over b. You don't have to stress yourself, you have to put it here. You're going to have 1 minus 1 over infinity. Remember, in number over infinity is 0, so our limit becomes 1. Our improper integral 1 to infinity of 1 over x squared dx gives us 1. Thank you for joining me in this video. See you in the next session as we delve into of improper integrals.